So now this week comes under force on a moving charge in magnetic field. Actually, this week you are entering into magnetics. Magnetic properties associated with a moving charge. That's the basic criteria. Like last week క్లాసులకు రాని వాళ్ళు ఎవరు ఫిజికల్ క్లాసులకు కానీ ఆన్లైన్ క్లాసులకు కానీ హ్యాండ్స్ రైజ్ చేయండి. లాస్ట్ వీక్ రాని వాళ్ళు ఎందుకు రాలా? ఏం కాల్ రాలేదంట? మిగతా వాళ్ళంతా లాస్ట్ వీక్ టోటల్ లెసన్ నువ్వు విన్నా ఆన్లైన్లో విన్నా. So therefore, we are dealing with magnetics. In electrostatics, majorly, you will deal with charges at rest, which means the different properties generated by that particular charge, like potential, electric field, etc. Now, we will deal with another property generated by a moving charge. Lorentz observed that when a charged particle is projected in different fields, exclusively electric field, exclusively magnetic field, combined magnetic and electric field, he observed that there is a deviation in its path. On the basis of his different experiments, he concluded that on his observations, how the charge experience different forces, he concluded the entire experimental setup into one single formula, a single equation that is called Lorentz equation, and the force is Lorentz force. If it is a pure electrostatic field, you know already QE bar is Coulombian force. But if it is in a combined field, it experiences additional force. You can see the additional force over here. This is the additional force. And that force is called, what is that? Magnetic force. Exclusive magnetic force. Magnetic force plus electric force together will contribute the total force, and that force is called Lorentz force. So if a charge is projected with a velocity v bar, vector v bar, in a magnetic field b bar, it will experience a force given by Fp is equal to, is it derived? No, it's not derived. Like your Coulomb's law, it is not derived. It is observed from nature and behavior of the charge in different magnetic fields. So this is like your fundamental equation. Fb bar is equal to qv bar cross b bar. Okay. See, when vectors were not there, it is very difficult for us to remember the direction of these forces. So then what they have given is, they have given you right hand thumb rule actually. They have given right hand thumb rule that time. So force experienced is given by right hand thumb rule. So you take left hand, stretch the left hand into 3 mutually perpendicular directions. Stretch your left hand into 3 mutually perpendicular directions. So by doing so, you can see the left hand here. In this left hand, force acts in this direction. Force mutually perpendicular directions. Left hand, first 3 fingers are stretched in 3 mutually perpendicular directions. If the pointing finger represents B bar, If the central finger represents V bar cross B bar is represented by the thumb finger. Why? Because that time vectors were not in the picture. Vectors were not in the picture. So therefore, if a charged particle is projected into a magnetic field, this will experience a force. If V bar and B bar are mutually perpendicular, F bar is perpendicular to both V bar and B bar. Now, for example, you just see when I am marking a cross means it is an inward, uniform, inward magnetic field. I just want to give you clarity on uniform. What exactly the term uniform refers to? Uniform by space and time. You take, Sanjana, you take any place, magnitude as well as direction is the same. That is the meaning of uniform. In such a field, you projected a charge with a velocity V bar. Now stretch your left hand, 3 fingers like this. Okay. Now point your pointing finger into the plane of the paper such that central finger is a tangent at the point shown. You see, you can see my hand here. My thumb finger, my pointing finger is into the plane of the iPod. Central finger is like a tangent along V bar. Now, where do my thumb represents? Upwards. Now, therefore, it is a perpendicular. As a result, it follows a circular path. Remember, all the time, force is perpendicular to velocity. All the time, force is perpendicular to velocity. Clear? All the time. So therefore, it follows a circular path. Remember, magnetic force does zero work. Why? There is no change in kinetic energy. Then what is the role of magnetic force? I told magnetic force does zero work. Palvita, what is the role of magnetic force then? Aditya, what is the role of magnetic force then? To change the direction of motion. So the role of magnetic force is just to change the direction of motion. That too provided V bar, B bar is mutually perpendicular to each other. And V will be perpendicular to F. Now, if there is a negative charge projected, if it is a positive charge, it follows a path like this. If it is a negative charge, it follows a path like this. Of course, both are circles. But you see, in the first case, the center is above the point of projection. In the second case, the center of the circle is below the point of projection. But still, it is a circle. Any doubt? Sir, why? Very simple. You said force is not V bar cross V bar. Force is Q V bar cross V bar. Previously, V bar cross V bar is in the upward direction because charge is positive. If the charge is negative, minus times V bar cross V bar means opposite to that. So therefore, it follows a circle like this. Next. Therefore, magnetic force FB, where it is moving in a circle, fine. And you know, if it is moving in a circle, it requires some centripetal force given by R omega square. So force is R omega square. What is the magnitude of this force? QV bar cross B bar, BQV. So BQV is the force that is actually centripetal here. So I am equating BQV or R MR omega square to MB square by R or BQV. Finally, I am having the expression for radius like this. I am having the expression for radius like this. You see, try to please understand there is no confusion here. BQV is mv square by r. So the radius of this circle is given by BQ. Don't forget mv refers to momentum. Now, by the way, how the charge gets kinetic energy? You won't give an impulse like kind of thing. For this is not a material particle, it's a charge. So you will accelerate this through some potential difference, somewhere which was not shown in the figure. Somewhere you have accelerated that across some potential difference V. So work done by that unit is Q capital V. Here it lies. Now this gives the kinetic energy. So therefore, you can write mv square as 2qv, or from this I can modify mv as root 2 m qv. This is the momentum. So that is the reason why in another terminology you can write r as root 2 m qv by bq also. So I have given two equations here. One in terms of mv. Two in terms of potential difference. Don't get confused. This is speed and this is the potential difference. If you don't want to write QV, write kinetic energy. So I have given expression for R in three different modes. Mode 1, MV by BQ. Mode 2, root 2 MQ capital V by BQ. Mode 3, root 2 MK by BQ. That is the expression for radius. And also you can give expression in terms of omega also. MR omega square is BQV. Hello, MR omega square is BQV. Right or not? So if it is BQV, what happens? What happens? So omega term becomes BQ by M. Angular frequency is BQ by M. Time period is 2 pi by omega, 2 pi M by BQ. Only from one single observation, you got three expressions for radius, one expression for omega, one expression for time period. Any doubts? Pakka? Right. Next. Now, previously what I have shown you, the entire space is filled with magnetic field. The entire space region is filled with magnetic field. Now it is totally different. Only certain length of the space is filled with magnetic field. Of course, uniform magnetic field. How I define that? You see, a space between x is equal to 0 to x is equal to d comprising this uniform magnetic field. Then what is my problem? So I have projected a charge. Now, there are n number of options. One, it would have taken a circle like this, but since the field is not continuously available, only this part remains circle. Rest again it will go straight line. Another possibility. This is another possibility. Right? Yes or no? This is another possibility. It may take a quarter circle and may move like this. Even it may take a circle and may move like this, semicircle. All these are possible. All these are possible. Therefore, this gap is d. And it is projected with velocity v. Now, at this point, it is going to be theta. Any doubt till this point? So please try to understand this is an arc. And this is the tangent here. This is the tangent here. If I connect all these lines, the point of intersection gives the center of the arc. And it described an angle theta, so it will deviate by an angle theta. Clear. So geometry says this is a D and this is R. Geometry says from this triangle, D by R is a sine theta. Of course, what is a theta? Theta can be given as omega t. Yes or no? Angular displacement is angular velocity times t. Because when it enters and leaves here, it will take some time t. So I have given you D term. D by R is equal to sin omega t terms. Suppose if D is equal to R, exactly one radius term. What happens? It will come and it will go fly off like this. If D is greater than R, what happens? It follows a semicircle. If D is less than R, what happens? This is what you will see. It won't complete even quarter circle. So it depends on how T by R are related. Any doubts, boys and girls? Now there is another case also related to the same. Okay, fine. Previously, introduction purpose, what I have done is complete region filled with magnetic field. Left, right, top, bottom. Everywhere you go, you have magnetic field. Now I have restricted magnetic field in between certain regions. Now in this entire left side, there is no magnetic field. My left, there is no magnetic field at all. To my right, continuously uniform magnetic field. In such a situation, I have projected a charge like this, and this makes an angle theta. Now, what has to happen? Apply Fleming's left hand rule. Everyone stretch your left hand, 3 fingers mutually perpendicular to each other. First set, pointing finger into the plane of the iPad. Next set, central finger in the direction of projection. What happens? Thumb is perpendicular to this point, like this. So here lies your center. So therefore, it describes a circle like this. It's an arc. I am assuming that this makes an angle phi. For example, I know that I have projected with theta. See, it is a symmetric distribution. It comes out with theta. Symmetric. Now, from geometry, if this is theta and this is 90 degrees, why? Because this is a normal, this is a tangent. This will become 90 minus theta. So 90 minus 2 times 90 minus theta plus phi is pi. So from this you can conclude phi is equal to 2 theta. That's what I have written over here. Sir, why I require this? Clear? If the arc describes a 2 pi angle at the center, it may take one time period. Boys and girls. If it takes a phi angle, it may take only some time t, not capital T. So therefore, from this I can give this relation. T is equal to phi by 2 pi times t. Phi by 2 pi times time period. Just now I have given you the expression here. 2 pi m by bq. That I am using over here. 2 pi m by bq. Finally, the time that I am getting is phi m by bq. It all depends on the angle described at the center. So how much time the charge spent in the magnetic field is decided on the angle that this arc makes at the center. Right. Next case, another possibility. You see that I have changed the direction of motion now. It is a negative charge actually. అయిపోయిందంటే అలౌ చేసిందా డబ్బులు కూడా తీసుకుందా వెరీ గుడ్ ఎక్కడికి పంపిస్తా రైట్ ఒక్క నిమిషం వస్తా So in what way this is different from the previous one? Negative charge. Negative charge means, now let's see how to handle negative charge by Fleming's left hand rule. I'll explain. If do everything as informed to nanu ఒక్క నిమిషం ఆశలో ఉన్నానని తెలుస్తుంది కదా రైట్ ఆ నెగటివ్ ఛార్జ్కి ఏం చేయాలి ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్ యూ టేక్ repeat do everything as mentioned earlier. What? Pointing finger into the plane. Okay, tangent along the direction of motion, central finger along the direction of motion. But You cannot break your thumb of your left finger just for this purpose. You take the direction exactly opposite to your thumb. Okay, got the point? For negative charge, don't break your thumb. You reverse the thumb in opposite direction. Imagine the thumb in opposite direction. For that purpose, don't break your thumb. Okay, next. So now what is the direction of the thumb in this case? The direction of thumb in this case is downwards not. It's not like downwards. This is the direction. It is like this, pointing towards this point. So therefore, this will describe a circle like this. Again, the same routine process. What is that process? I am assuming the angle here described is alpha, but that is wrong. Previously, I took this as phi. In this case, you should not take that as a phi. No, it is not like that. You should not take that as your criteria. Why? I will explain. See, you extend these lines here. If this is phi, what is this? 2 pi minus phi. Always exterior only, outside one only. No confusion. I am teaching this again. These lines are mutually perpendicular to each other. If this is phi, this is 2 pi minus phi. Correct or not? That's all. Correct or not? So therefore, what is that you need to take is this angle. This is the angle corresponding to the time spent. So if this is a 2 pi, you would have written t. 2 pi minus phi, t. So the time spent, according to my observation, is this. But don't forget, still phi is a 2 theta only. Boys and girls, do you have any doubt in this? If this is done, 1/3 of the chapter is done. And remember, this chapter I am telling you again, see, for certain movies, particularly horror movies, they will describe before starting of the movie. Those who are heart patients, those who are tense, those who are having problems of fits, etc., don't watch this movie. Similarly, this week onwards, I will teach very basic questions, simple application. Straight away, I will teach Pathfinder questions. Why? I told you very clearly, from these chapters onwards, we will find a very less time for revision. So your revision must also be planned during this session only. So you should be very clean in this preparation. Are we clear? Right. We'll move on to the next case. So in all these occasions, yeah, please ask me. Pi minus pi, 2 pi minus pi in Japan, it is pi minus pi. మనం ఈ యాంగిల్ తీసుకోవాలి ఇక్కడ. ఓకే, రైట్. పై మైనస్ పై అవుతుంది. Right. In all these cases, case 1, case 2, case 3, in all these cases, what is that you would have observed is charge is projected at right angles to the magnetic field. What if the charge is projected with some angle made with the magnetic field? I repeat, what if the charge is projected, if this is the direction of the magnetic field, and I have projected it with an angle theta? You can assume two components. One component is along the magnetic field, another component is perpendicular to the magnetic field. The component perpendicular to the magnetic field will try to rotate the charge in circular orbit. But whereas the component along the direction of the magnetic field will pull the circle. Instead, it follows a path like this. This is the path. And again, second repetition. And again, third repetition. Likewise, such a path is called helix. Helix, Helix. Helix. Path, helical path, whatever it is. One rotation is a helix. Plural, helical path. right? And I'll start here. One rotation is completed. Here in this case, if it is a pure circle, these 2 points coincide actually. Yes or no? But because of the component of velocity along the direction of magnetic field, these 2 points are separated. And this distance is called pitch. P-A-T-C-H, pitch. Who is responsible for pitch? V cos theta component is responsible for the pitch. So therefore, the pitch is given as V cos theta into one time period of rotation. Still time period is 2 pi m by bq. See, in original formula also, omega or t is independent of V by 2 pi m by bq. Now, where is V in that? There is no V term. Therefore, pitch is given as like this. Now, suppose an observer who is observing here, if he is projecting the image, if he is focusing a light on a screen here, he see that the particle is moving in a circular orbit like this. It is a circular orbit. So R is mv sin theta by bq. R is mv sin theta by bq. Radius is mv sin theta by bq. So this is a helix and this is the path. Suppose you can imagine the helix path like this. Imagine a very long cylinder whose radius is mv sin theta by bq. Okay. And magnetic field is along the axis of that cylinder. So actually, the entire charge is confined in that cylinder. It goes like this within the cylinder. And this gap is pitch. Got the point? Sure? So I have done 2 cases today. One, charge projected. If the charge is projected along the direction or opposite to the direction of magnetic field, nothing happens. Why? Why? Along the direction, Q V bar cross B bar is 0. V bar cross B bar is 0. Sin 0 degrees, 0. So therefore, no effect of magnetic force. Even if there is magnetic field also, my charge will not respond. This is a special case. If the charge is projected either along the direction of magnetic field or opposite to the direction of the magnetic field, what happens? Force becomes 0. It goes straight line path. So today I have introduced 3 things. 1, charge projected perpendicular. 2, charge projected with some angle. 3, charge projected along the direction of motion of P. Any doubt till this point? See, just because that I have these notes, I have covered 5 pages content. You come with the printout of this, which I just, I'll confirm whether ఇందులో 2 notes ఉన్నాయి. ఏ notes పెట్టారో నాకు డౌట్ గా ఉంది. ఈ notes రావాలి. ఎవరి దగ్గర ఉందా notes పెట్టింది? Okay, I just have, let me just confirm. ఇదే పెట్టాను. Right, no issues. I have done this one. Right. Next case. Now my problems will start. Today's class is utmost important again. It's a very fundamental and elementary level teaching is happening. I'll discuss question paper in the evening, sometime later. అవసరమైతే రికార్డ్ చేసి పెట్టేస్తాను క్వశ్చన్ పేపర్. రైట్, 1 minute again, ఒక్క నిమిషం. So till now, we were working on charge projected in magnetic field alone. Boys and girls, alone. Now you have a combined magnetic and electric field. First, I will complete the entire theory, then we will go for numericals. That is better. I think you got my point. First, we will complete the total theory, basic theory. Because if I start, what will happen, right? Now, here in this case, what I am doing is, I have a combined magnetic and electric field. See, different combinations in numericals anyway I will cover. Fundamental cases, I will cover it right now. Now you see crossed lines like this. They represent a uniform inward magnetic field. And you can see, I can set an electric field like this. You know how I can set electric field. It's like between the region of a long parallel plate capacitor plates. You can imagine some circular discs kind of thing. And in that circular disc, not at the edges, in between this region, you will have a uniform electric field. Now, along this line, I have projected a charge. Suppose the charge enters here, and imagine that its velocity is in that direction only. Apply Fleming's left-hand rule. Stretch your left hand, first three fingers mutually perpendicular to each other. Set the direction of the pointing finger into the plane of the paper. Set the direction of the central finger rightwards. Now your thumb is upwards. Yes, so that I have represented FB. I'll repeat again. See, pointing finger is into the plane of the iPad. Central finger is rightwards. And upwards you have thumb. But thumb represents magnetic force, FB. Now you have the charge Q. Now this charge will experience a downward force because of the electric field. Now at this instant, assuming that it is going in the straight line path, that particular charge is experiencing an upward force and a downward force. What if they cancel each other? I repeat. And remember, except these two, there is no other force. Ignore gravity here. Ignore gravity effect. Except these, there is no other force. What if they cancel? What happens if they cancel? Are net force is 0. ఇక అందుకే నీకు మార్కులు రానివి. ఎలా సర్క్యులర్ పాత్ అవుతుంది? సర్క్యులర్ పాత్ కొనటానికి ఏం కావాలి? సర్క్యులర్ పాత్ కాదా? అప్పుడు ఏమవుతుంది? అది ఎందుకు స్ట్రైట్ లైన్ పాత్లో పోతుందని చెప్తే పోలా. There is no force. Practically, there is no force to deviate the direction of motion. It goes along a straight line path. Don't say any other thing apart from this. If there is only electric field, what path you suggest? Only electric field unte em path lo veyade? Only electric field unte. Only electric field unte ఏ path అయ్యేది? It is like a body projected horizontally from the top of a tower. What is the path of that particle? Parabola. If it is only magnetic field, చెప్పరా ఇప్పుడు? If there is only magnetic field, it is circle. And in this case, both are available simultaneously. So that the net force is 0. So as if there is nothing, it goes in a straight line path like this. So here you can see net force is 0. Net force is 0. In fact, V bar cross B bar plus E bar is 0. That you can modify it as E bar is equal to B bar cross V bar. E bar is equal to B bar cross V bar. If this condition is satisfied both by magnitude and direction, you will have this. Undoubtedly, B, V, E, mutually perpendicular. So B cross V is BV sin 90. BV, E is BV. So V is E by B. Remember, this is a very important condition in mass spectrography. There is a mass spectrography you may use in isotopes and all that. To separate different isotopes, you will use this technique. And this is also called as velocity sector condition. Remember, independent of charges, those who are having these velocities, they will go undeviated. And those who are having different velocities apart from this, either they will go up or they will go down. Only those charges that satisfies this condition will go in a straight line path. This is how you will separate different isotopes. And this is the principle used in mass spectrography. Okay. So therefore, that velocity condition is called velocity sector condition. I am asking you, do you have any doubt in any of these equations? Please ask me right now, boys and girls. Any doubt? Gaurav? Right. Next case, now your problems will start. The level of difficulty keeps increasing now onwards. Now, E bar and B bar are parallel to each other and a charge Q is projected perpendicular to E bar. Can you see the directions of E bar and B bar in the diagram? Where were they? Both are in Y direction. And you are projecting it along X direction. I'll ask you one question. If there is no E, what would have been your observation? You are here. You are here. What would be your observation? It goes in a circular path. It goes in a circular path like this. Okay? It goes in a circular path like this. But if there is electric field, if there is no magnetic field, what would have happened? It would have gone, one component is in this direction, another component is in this direction. It would have gone like this, parabolic path. But magnetic field exists. So as a result, what will happen? The magnetic field will rotate this component. Besides, there is acceleration in the direction of Y. As a result, it may go in a helix path, but not uniform helix. Means, if the pitch is X here, the next pitch is not going to be X. So it goes in a helical path with increasing pitch. I'm asking you, do you have any doubt till now? Pakka? Now the question is, now you said that this is moving in a circular path. Yes or no? For example, you imagine that this is X Z plane. At this instant, it is having this V naught velocity. And one more component towards you, actually. Right. Now, say this has described an angle theta. If anyone, don't forget, I said this is x-axis, z-axis. Right. So now, therefore, what is going to be this distance? This is x sine theta. X is r sine theta. Allowed? Boys and girls. Don't forget, theta is omega t. Here also. Right. Now, what about z component? You want z component also, this distance. Right now, z is nothing but, this is r cos theta, actually. This is r cos theta, yes or no? This is r, this is r sin theta. And what about this? This is r cos theta. And the total distance is r. And this is the z coordinate. So what is z? R minus r cos theta. So therefore, I have z here like this. Right. So it is a helical path with increasing pitch that we know. So I have given you Z coordinate, X coordinate, Z coordinate. Don't confuse. I am giving you Y coordinate also. Now in the direction of Y, it is only acceleration in the direction of Y is electric field. QE by M. That is the acceleration. Yes or no? Array, only force in the Z. Array, don't get confused. Your magnetic force will be always perpendicular to V naught term. Your magnetic force is always perpendicular to V naught term. Electric field force is always along bidirection. So therefore, I have given you X coordinate, I have given you Z coordinate, I have given you Y coordinate. It is your choice. You ask me time. Just mention time. I can give you your X, Y, and Z coordinates as it is. Now I am still asking, do you have any doubt in this observation? What case will this come under? Both E and B parallel to each other and charge is projected perpendicular to that. Charge is projected perpendicular to that. Any doubt till this point? Boys and girls? Pakka? Next. This is the most important case and this is the most difficult stage that I might face. But I will teach this bit later because if I don't deal some problems, you will get bored. Therefore, I will get into the problems. Right. You please go through this question once. Direct substitution based. That is the reason I'm not giving much priority to this. Can you see that a magnetic field of so and so exerts a force on a particle having a charge of so and so and going in xy plane? Find the velocity of the particle. If it is in xy plane, it will have only Vxi cap plus Vy j cap components. There won't be any Vz component. Right. So I am taking, you said very clearly, magnetic field of 5 into 10 power minus 3 kr, k cap along z direction actually, Tesla. What I am going to do is, I will do a cross product between V bar and B bar. Will you accept that? V bar and B bar. So what I will get is, in this process of doing cross product, what I will get is Vx cross Vx I cap cross k cap. I cap cross k cap is minus j cap. I got minus j cap. 5 into 10 power minus 3 into Vx. Similarly, Vy j cap cross k cap is plus I cap. I got the plus. So I got V bar cross B bar, this relation. Now, honestly answer me, have you understood that V bar cross B bar? Pakka. Into charge gives force. Right. But you have given me force, by the way. You have given me force. What I am going to do is, I will multiply charge with this term. So I will get some I cap component and some j cap component. Now I will equate this I cap component with this j cap component with this. That allows me to find Vy and Vx. Here I have Vy, here I have Vx. So V bar is what I got, minus 30 I cap plus 40 j cap. So magnitude of V is 50 meter per second. I am asking again, do you still have any doubt in this? Any elementary levels, Sanjana? Pakka? Sure. Go through this question. A charged particle of mass m and charge q starts sliding from rest on a vertical fixed circular track of radius r from the position as shown in the figure. There exists a uniform, can you see that uniform magnetic field in that? No, no. Dots are there. Dot means outward magnetic field. There exists a uniform and constant horizontal magnetic field of induction B. Find the maximum force exerted by the track on the sphere. Right. Now see, at an instant, when the velocity is v, I will start working. Repeat. At an instant, the velocity is v. Agreed? By that time, it has described an angle theta. Agreed? Now, one force is mg, weight force. Are boss, Fleming's left hand rule. Now point your, stretch your first three fingers of left hand mutually perpendicular. Show the pointing fingers towards you, outward, towards you, towards you. And this is the tangent. Tangent. Outwards, tangent. Now, thumb represents what? Normal force. No, magnetic force, sorry. Magnetic force is like this. Now here lies normal reaction force. In the rotating frame, pseudo force mv square by r acts backwards. I am asking again, have you identified the real forces? Weight force, magnetic force, normal reaction force. In the rotating frame, additionally, you will have mv square by r. If this is a theta, this is a 90 minus a theta, and hence this is 90 minus theta. So what is normal reaction here? The normal reaction here represents, if this is mg, this is mg sin theta, mv square by r, and bqv. So normal reaction is mg sin theta plus bqv plus mv square by r. You give me v, I will give you everything. Find the maximum force exerted. Okay, 1 minute. Now here, I told you very clearly, magnetic field does zero work. This is r sin theta. So loss in potential energy is gain in kinetic energy. Please tell me, will you agree in writing this or not? Anyone would like to question me about the existence of magnetic force? Sir, you didn't consider magnetic force. Likewise, you have any doubts? Mahant. Then why not I ignored magnetic force? Is this equation wrong or right? Why? Magnetic force always does zero work because the force is always perpendicular to. So therefore, only work source is the weight. So now V can be written as root 2 or G sin theta. Now you come back to this equation again. You come back to this equation. Normal reaction is mg sin theta plus VQV root 2 or G sin theta plus mv square by r. mv square by r is 2mg sin theta. So normal reaction is 3mg sin theta plus bq times root 2rg sin theta. It is a function of sin theta now. Now you do dn by dt is equal to 0. You got 3mg cos theta, okay, plus bq times root 2rg times 1 by root sin theta differentiation is 1 by 2 root sin theta into differentiation of sin theta is equal to 0. Now you have one expression in terms of sin and cos. Now solve this, you will get angle. You got the point? Now just solve this. So what I can do is I can take root sin theta as 1 minus cos square theta. So you will get some expression for cos square theta because it's a quadratic. So by solving properly, you will get the required answer. Okay. Because I'll solve it. Why should I hesitate? I'll solve this. If you permit me, I can make it as root sine theta times cos theta plus BQ root 2RG by 3 mg, 6 mg times cos theta is equal to 0. Allowed? Or your entire thing you represent with some phi because you cannot repeat n number of times. So root uh, sin theta plus phi times cos theta is 0. Cos theta cannot be 0, right? 1 minute. You expand this. Write this as 1 minus cos square theta. Cos theta is minus phi cos theta. Squaring on both the sides. 1 minus cos square theta is phi square, right? Any doubt till this point? కదా ఒక్కసారి చెప్పు రూట్ 1 minus cos square theta root of root or 1 minus cos square theta is 5 power 4. So cos theta is 1 minus 5 power 4 whole to the power of 1 by 2. So I have given you answer. Who will solve here? That is the concept. That cos theta, you will have normal reaction maximum. Any doubts? It's a basic question. You may expect this question. Are we clear on this question? Everyone try to go through this is an elementary question. The magnetic field is confined in a square region. A positive charged particle of charge Q and mass M is projected as shown in the figure. Find the limiting velocities of the particle so that it may come out of the phase 1. Can you see, locate 1? Here, can you locate 1? This is 1. This is a 2. This is a 3. This is a 4. Right. Right. Now, for example, if you want to come back through the phase, this is the condition, which means L by 2, the term L by 2, at least 2R, or L by 2 greater than 2R is also okay for me. Hello? L by 2 greater than 2R అయితే ఏమైపోతుంది? L by 2 is equal to 2R అయితే ఇది కండిషను. L by 2 greater than 2R అయితే ఈ లోపలే వచ్చేస్తుంది. ఈ లోపలే వచ్చేస్తుంది. Yes or no? So therefore, the condition L by 2 is equal to 2R, 2mb by bq, R means mb by bq. So from this I can say V less than or equal to BQL by 4m. In this condition, it comes out from phase 1. What is the condition for phase 4? Phase 4. What is the condition for phase 4? See, for phase 4, this is the condition. It enters here. This should be the limiting point. I have given, arc type or here D space. What is the condition here? In the place of D, you have L. D is equal to R sin theta. Allowed? L is equal to R sin theta. Allowed? Right. What is L by the way? What is L by the way? L is nothing but R sin theta. ఒక్క నిమిషం ఇది theta అయితే L వచ్చేసి R sin theta. Right. So R sin theta. Okay. By the way, one more important point is there. By the way, what is R? R can also be written in another way. If this is R, this is R cos theta. R cos theta plus L by 2 is R. Yes or no? That also I have substituted here at this point. So finally, the condition what I am going to get is cos theta plus sin theta by 2 is equal to 1. Finally, tan theta by 2 is 1 by 2. You will get the condition tan theta by 2 is equal to 1 by 2. This is theta by 2, 1, 2. Right. Now again you come back. L is equal to R sin theta. Don't forget that. You bring that over to here. L is R. What is the sin theta from this? What is the sin theta from this? You know sin theta by 2. Array, sin theta can be written as 2 sin theta by 2 cos theta by 2. 2 times 1 by root 5 and 2 by root 5. What this becomes is 4 by 5. So therefore again come back. L is equal to R sin theta. L is R times 4 by 5. R is 5L by 4. Don't forget our R is radius of curvature in magnetic field. MV by VQ. So V is equal to 5BQL by 4M. If you have this much velocity, what happens? It will enter through this point. What if the speed is lesser than this? It will not move. It will go like this. Got the point? You have one condition for this point now. Previous one. V is equal to BQL by 4M. You got a fresh condition for here right now. 5BQL by 4M. So if your speed lies between 4BQL by 4M to 5BQL by 4M, definitely it comes out through phase 4. What if it is more than 5BQL by 4M? It comes out through phase 3. Is it possible to come out through phase 3, phase 2? No. So long it is positively charged, it will never come through phase 2. So that also you should mention. It will never come out of phase 3. Phase 2. Phase 2. So I have given detailed condition, but still I am asking again, are you clear about this? Pakka? Right. Now you try to do this. I am giving very basic questions only. Try to do this, everyone. Read the question carefully. Where will we do mistakes? In reading the question properly. Uniform magnetic field B naught is present in a region along Z direction. So always we will feel Z is above towards us. Positive Z is towards us, which means I am assuming that there is some inward magnetic field, I am assuming. Outward, sorry. Inward ఉండకూడదు ఇది. Outward కావాలి. Right. What is the question? The chargeable having specific charge means Q by M is equal to sigma. నేను అట్ట అనుకుంటా నేను కొట్ల The direction of the magnetic field is made to reverse after every 2 pi by sigma b. Are first of all, what is the time period? T is equal to 2 pi m by bq. దీన్ని ఏమని రాసుకోవచ్చు 2 pi by b sig. థ్యాంక్స్ రా. వాడు ఎవ్రీ 1 కంప్లీట్ టైం పీరియడ్కి మారుస్తున్నాడు. లేకపోతే మనకి దరిద్ర పరిస్థితి వచ్చేది. రైట్. ఫర్ ఎగ్జాంపుల్ నేనేం చేస్తున్నానంటే చార్జ్ని ఇలా ప్రొజెక్ట్ చేస్తున్నా. ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్. అరే పాయింటింగ్ ఫింగర్ టువర్డ్స్ మీ, central finger along the direction of V, then thumb represents in this direction. What happens is it will describe a circle like this. By that time, one time period is done. The next immediate moment, what happens? Field is changed. It is no longer outward. I apply Fleming's left hand rule again. Outward and inward, direction of motion left. Like this, set the finger. Pointing finger into the plane of the iPod. Central finger along the direction of velocity. But now thumb is directed downwards. Now what happens is there is a change in path. Right. There is a change in path. So this is the first set. And this is the next set. What do you want, by the way? What are the farthest points that you notice. These 2 points, C and D. These are the 2 points. Farthest points. అదకన్నా ఉంటాయంటే చెప్పండి. Okay, fine. I am ready to listen. As per my mathematics knowledge, this is the farthest. Yes or no? You take point C as a reference. You imagine a circle. So this is the maximum radius. Therefore, the point CD, what is the distance CD? Can someone explain me? 4R. 2R plus 2R. 4R. 4 times MV by BQ. 4V by B sigma. Any doubts? Right. Are we clear about this question? Pakka? Any doubts? ఇక్కడేమో నో అంటారు, పరీక్షల్లో మార్కులు రావటంలా. ఏమైంది? లాస్ట్ వీక్ బాగానే చెప్పాక ఎన్నో మోడల్స్ చేయించారు. ఏమైంది? క్వశ్చన్ పేపర్లో ఏమైనా డీవియేషన్స్ ఉన్నాయా? ఏరా ఆ చివర ఏదో చెప్పాడు, నాకు వినిపిస్తలా. దీనిలో ఏమైనా డౌట్ ఉందా? ఎనీ డౌట్? నెక్స్ట్ క్వశ్చన్, గో త్రూ దిస్ everyone. Read the question carefully. They have given kinetic energy, mass, charge. There is a plate at a distance 10 power minus 2 meter from the end of the tube and placed perpendicular to the beam. Right. And you have inward magnetic field in this region. Right. And that distance is D for my observation. So D is 10 power minus 2 meter. M is 8 into 10 power minus 27 kg. Charge is 1.6 into 10 to the reverse, sir. A beam of charge having kinetic energy contains masses, 2 different masses. M1 1.6 into 10 power minus 26 kg. There is a plate at a distance so and so from the end of the beam, place it perpendicular to the beam. Calculate the magnitude of the smallest magnetic field that can prevent the beam from striking the plate. ఏందబా ప్లేట్ నువ్వు వేసో ప్రొజెక్ట్ చేసావు. చెప్పాలి డైరెక్షన్స్ ఏంటి? ఇన్వర్డ్ మ్యాగ్నెటిక్ ఫీల్డ్, ఇన్వర్డ్ అంటే ఇక్కడ ప్రొజెక్ట్ చేసుకోండి. అప్పుడు ఇక్కడ ప్రొజెక్ట్ చేసుకుంటే అదేం చెప్పలేదు, ఎక్కడి నుంచి లేదు. ఇన్వర్డ్, డైరెక్షన్ ఆఫ్ మోషన్ రైట్ వర్డ్స్, upwards. So what is the condition? In this condition, you can avoid. And D must be the radius. But see, what is the formula for radius? MV by BQ. But they have same identical charges. My problem is, study this now. This one is having more mass than this. ఇప్పుడు దేన్ని నేను తీసుకోవాలి? ఇప్పుడు హయ్యర్ మాస్ రేడియస్కి తీసుకుంటే లెస్సర్ మాస్కి సరిపోతుందిగా కండిషన్. మీకు ప్రాబ్లం అర్థమైందా? ఓకే. R is equal to MV by BQ. I will expand this further. 2 times mass into kinetic energy by B into charge. మీరు ఇప్పుడు ఫార్ములాలో చూసినట్లయితే B వచ్చేసి 2mk by q into r. సో అన్ని సేమే, k సేమ్, q సేమ్. ఇప్పుడు r ఎంత తీసుకోమని చెప్తున్నా నేను? d ఎంత తీసుకోమంటున్నా. సో ఫర్ ద పార్టికల్ ఆఫ్ లార్జర్ మాస్, if this satisfied for particle of larger mass, B required is more. If the condition satisfied for larger mass, automatically the lesser mass will also be considered. Sir, మమ్మల్ని మోసం చేస్తున్నా, నేనేం మోసం చేయటల్లా. For example, this is the path for larger mass. What is going to be the path for the lower mass? Simply it will go like this. Lighter one. So here B minimum is 2 times m large k by q into r. So therefore you just substitute in this 2 into larger mass is 8 into 10 to the power of minus 27. Kinetic energy 10 power 3. Don't substitute in that units. Into 1.6 into 10 to the power of minus 19 by 1.6 into 10 power. Yeah, any doubt? Oh, right. Good, thank you. 1.6 నేను 1.10 పవర్స్ చూసుకోవాలి కదా. గుడ్ అబ్జర్వేషన్. 10 power minus 26, 10 power minus 27 into radius. Radius is 10 power minus 2 meter. Just solve this. We will get a simple calculation. This one 1.6 బయటికి తీసేయచ్చు. బయట 1.6, 10 power minus 26, 10 power minus 19. ఇక్కడ రెండు 10 power minus 19 కూడా తీసేయచ్చు. What is contained in the root? 1.6 into 10 power minus 19 by 1.6 into 10 power minus 19 into within the root 2 into 10 power minus 7 plus 3. 10 power minus 4. దీని లోపలికి తీసుకెళ్తే 10 power minus 4. Therefore, it is root 2 Tesla. 1.414 Tesla. Any doubt? Boys and girls? Pakka? Sure? No, it is up to you. Apply the concept. Apply the concept. Charged particle having charge q and mass m is projected at an angle alpha with x-axis with magnitude of velocity v0. The magnetic field having charge B is along x-axis as shown in figure. Find. Helix. So again, you need to do this problem in 2 ways. Suppose you are standing over here, right or not? You will see that field is outwards and this component V0 sin alpha is like this. Yes or no? Boys, this is y-axis. This is negative z-axis. Into లోపలికి ఉంది డయాగ్రామ్. అవుట్వర్డ్ రా ఫీల్డ్. చెప్పండి ఇప్పుడు. అవుట్వర్డ్ అంటే మీ వైపుకి పాయింటింగ్ ఫింగర్. సో మ్యాగ్నెటిక్ ఫీల్డ్స్ ఈజ్ లైక్ దిస్. వాట్ హ్యాపన్స్ హియర్? It goes a circular path like this. Any doubt? Pakka? Now the question is, at an instant when this is here, this makes an angle theta. What is y coordinate? Can you please help me in writing y coordinate? What is y coordinate? Y coordinate is r sine theta. And don't forget what is r. mv naught sine alpha by bq. Don't forget that. R sine theta. Theta is omega t. And don't forget what is omega. T is 2 pi m by bq. Omega is bq by m. What is z coordinate? Actually, minus, I know. Z coordinate is minus of. Actually, మీకు కావాల్సిన కోఆర్డినేట్స్ బాగా జూమ్ చేసి చూపిస్తున్నాను చూడండి. మీకు కావాల్సింది ఈ కోఆర్డినేట్, బట్ ఈ టోటల్ అంతా ఎంత ఆర్, ఇదెంత ఆర్ కాస్ థీటా. సో దేర్ ఫార్ మైనస్ ఆఫ్ ఆర్ మైనస్ ఆర్ కాస్ థీటా. ఇది జెడ్. ఓకే, బాగానే ఉంది. మరి ఎక్స్ ఏమవుతుందంటే కాన్స్టెంట్ స్పీడ్ along the direction of magnetic field. V cos theta into t. So I have given x coordinate, I have given y coordinate, and I have given z coordinate. Now if you ask me the position vector at any time, here it is V cos theta into t I cap plus r sin theta j cap minus r times 1 minus cos theta k cap. Boys, any doubts? Differentiate this. If you differentiate this, what you will get? Velocity. Actually, foolish thing. Speed is constant because magnetic field does no work. No work. So even here at this point also I can show you. Very simple. At this point, this is how your V naught sine alpha. At an instant t, that is the picture. Now you resolve this again. If this is a theta, this angle is a theta, this angle is also theta. And this angle will become 90 minus theta. Now you give me Vy component. Boys, Vy component is V naught sine alpha cos theta. Array, 90 minus theta kada. Cos theta. Vz component వచ్చి minus V naught sin alpha sin theta. Vx component వచ్చేసి foolish thing. Always constant V naught cos alpha. So therefore, if you want velocity term, V bar is, boys, V bar is V naught cos alpha I cap plus V naught sin alpha times cos theta j cap minus ఏమైనా తప్పుందా? sin alpha naught. Cos theta j cap minus sin theta k cap. Any doubts? Pakka? Right. So we'll move on to some more theory. So I have done some sufficient models. This is a very important theory. చెప్తారు హోల్డ్ యువర్ బ్రెత్ అంటారు చూసారా, ఆ టైపులో జాగ్రత్తగా వినకపోతే కొడతా కూడా నేను. రైట్, This is the utmost case. N even ఇప్పుడు గ్రాండ్ టెస్ట్ లో కూడా దీని మీద క్వశ్చన్స్ అడుగుతూ ఉంటారు. ఈ పిల్లలు గుర్తుంచుకోరు అవి. అందుకే లాస్ట్ 15 minutes కి ఇది స్పేర్ చేశారు. Now what is that you have is, you have a charged particle. You imagine a region of space where you have x-axis along which x direction you have electric field, uniform electric field in this direction, right? And you can see dotted lines means outward magnetic field, right? The problem is you have released a charge at origin. Suppose if there is no magnetic field, what would have happened? There are no green dots, for example. What would have happened? If there are no green dots, what would have happened is it is only electric field and it would have gone through a straight line path along x-axis. Agreed, boys and girls? Boys and girls? Agreed? Right. Now the question is, right, it's going along a straight line path, right? But because there is magnetic field, what happens? Initially, there is no velocity in the direction of E. Slightly velocity starts towards x-axis. Immediately, magnetic field turns that. How? Stretch your Fleming's left hand rule. Fleming's left hand rule. Field outwards. Central finger along x-axis. Thumb is along z-axis. So it starts to take a turn. But as it moves rightwards, speed keeps increasing because of the work done by the electric field. As the speed increases, it turns. And some point, what happens? It reaches, its velocity becomes parallel to z-axis, perpendicular to x-axis. Now it goes in opposite sense. See, from here to here, speed increases. From here to here, speed decreases. And finally comes to instantaneous rest. And this process repeats. Such a path is called cycloid path. Okay. That is all introduction only. Don't worry. I'll prove it right now. I'll prove it right now. Now, agreed? Agreed with this? Agreed with this? B bar is outward. Outward means it is in the direction of k cap cross I cap. Right. What is the equation of the path? Right. I know equation of the path can be given by Newton's second law, F naught is equal to ma bar. Ma bar is due to two forces. One is Fb, the other is Fe. Sanjana, I am telling you again. I'm telling you again. These are the only two forces. There is no other force. Don't consider weight, etc. like kind of thing. Now, what is we already know. It's a very common sense. The entire velocity is in the xz plane only. So it won't have any y component. See there, xz. It moves in xz plane only. There is no y component. So therefore, what is V bar? Vxi cap plus Vz k cap cross Bj cap. Is this clear? Is this clear? B bar is outwards. B bar is outwards. It is not Bj cap. Actually, I should write, yes. K cap cross I cap is J cap. Therefore, Bj cap plus QE I cap. Agreed? Everyone, just put your focus on this point. Agreed? Boys and girls, Pakka. Now you do the cross product. I cap cross J cap is K cap. K cap cross J cap is minus I cap. So after doing which, Ma bar can be written as QBVX K cap minus QBVZ minus I cap plus QE I cap. Now you have two terms for I cap, a single term for K cap. Agreed? Now what is that? QBQVX K cap, QE minus BQVZ I cap. Now I will equate I cap terms on both the sides and the K cap terms on both the sides. Now I am equating I cap components. Carefully observe. నీకు నిద్ర వస్తుంది ఏసీ రూమ్లో కూర్చోపెట్టి పాఠం చెప్తూ ఉంటే హాయిగా మీరు అక్కడే సార్ దగ్గరే వినండి. మీరు నేనేమో ముందర నోట్స్ తయారు చేసి తక్కువ టైంలో అంటే ఇది 2 days క్లాసెస్ పడతాయి. నేను బోర్డు మీద టీచింగ్ చేస్తే విత్ నోట్స్ అండ్ ఆల్ దట్ ఎన్ని రోజులు పడుతుంది? 2 classes పడుతుంది. నేనేం చేస్తున్నా ఫస్ట్ మండే రోజునే సిలబస్ పూర్తి చేస్తున్నాను 50%. రైట్. m dvx by dt is అరే యార్ vx అంటే ఇదే కదా, dvx by dt is q by me minus bq by m vz. ఈ ఈక్వేషన్ ని do differentiation with respect to time. You will get d square vx by dt square is 0 minus bq by m times dvz by dt. You have any doubt till this point? Just please give me clarity. Right. Any doubt till this point? So therefore, you can simply write d this entire thing as bq by m. Okay, by the way, hold on. Just stay here. Stay till 4. We'll go right side now. This is the picture. dvz by dt is equal to bq by m bx. Agreed? Or here I just reframed. Now I will use that here. So that I will get d square vx by dt square is minus bq by m bx. Now this equation can further be reframed as something like this. We'll take omega as bq by m for a while. So it is a d square vx by dt square plus omega square v. Have you ever seen such an equation? Hooray. D square x by dt square plus omega square x is equal to 0, SHM. So harmonic oscillator equation. So here Vx is something, it will be of this form. Vx max sin omega t. Sir, మీకు అలా ఎలా తెలుసు అంటే I know initial conditions. At t is equal to 0, V is 0. అంటే అప్పుడు ఫంక్షన్ ఏం కావాలి? sin omega t. Any doubt till this point? Boys and girls. Next. Now you do the differentiation of this. dvx by dt. This is omega Vx max cos omega t. We know at t is equal to 0, V is equal to 0. Right? We know at t is equal to 0, V is equal to 0, and only acceleration is along x direction, that too QE by m because of the electric field. So I am substituting that part here. QE by m is equal to BQ by m times Vx max. Now I got an expression for Vx max. Vx max is nothing but E by B. Vx max. Right. Now I got Vx equation. Right. I got Vx equation. I'll substitute that Vx equation here. I'll get another situation like this over here. With this, I'll get Vz. Sir, whether you followed entire track or not, in exam you won't derive all. In exam, at least you need to remember these two equations. E by B sin omega t, E by B 1 minus cos omega t. Right. What is Vx? Dx by dt. So that's what I have taken here. So this allows me to write x. This allows me to write z. If the x and z coordinates satisfy this condition, it is called as, this condition is called as cycloid. The path is cycloid. If x coordinate and y coordinate behaves like this, it is called cycloid path. So the entire expression, I require only these 4 equations. Everyone please go through this. The z component velocity is E by B 1 minus cos omega t. X component is E by B sin omega t. X coordinate, Z coordinate. These 4 I want. Now tell me, give me your feedback about those 4. Are we clear on this? ఎదురు రాదురా? ఎక్కడ రాదు? లిమిట్స్ తీసుకునేటప్పుడు సైన్ ఒమేగా టీకి కాస్ ఒమేగా టీ వస్తుంది. ఇనీషియల్ గా 0 పెడితే 1గా వచ్చేది. ఆర్ వి క్లియర్? రైట్. Those 4 terms are important for me. Those 4 terms are important for me. Okay? So I'll continue on this in my next class. So I'll